Good morning, good afternoon, or good evening to our attendees wherever you're logged in from. I will be your host. My name is Ricardo. With me, we have Ashok Patel and Dr. Michael Slenkridge. Today will be our first webinar in the series of SimManager for 2023. And I'd just like to give a brief introduction to our two presenters for today. We have Dr. Michael Slenkridge. He is a highly respectable expert with almost 3 decades of experience in simulation process and data management and cloud topics. He has a rich background in theoretical physics and has made significant contributions to the development of industry-leading SPDM solutions. Notably, his tenure at Silicon Graphics collaborated with BMW to create the groundbreaking CAE bench system, revolutionizing the simulation process. Also with him, we have Ashok Patel, who is a professional with almost 16 years of experience and almost a decade of experience in SPDM. He specializes in SPDM and has a strong focus on CAE tools, particularly SimManager. We are honored to have both of them today to talk about SimManager and share some insights on the new developments.
Okay. So Ricardo, thanks for the introduction, and good morning and good afternoon to all the attendees. So my section right here is I will do the introductory part of motivating SPDM, really kind of like setting the stage of what we want to accomplish with our solution, with our next generation SimManager solution, and what were kind of like the basic motivations around the design that we put into this new system. So with that being said, I want to start with our heritage, with the 60 years of expertise that we have in the D&E organization, or formerly MSE Software, on simulation. And what I do want to point out is that 60 years ago up until now, the main important thing of simulation is to do the right simulations, to make sure that the mission for which you do the simulation is successful. If it was 60 years ago, the Apollo program and landing on the moon and getting the people safely on the moon and back, or if it's today to launch a successful product into the market, manufacture it, and operate it in the market, it's always simulation is there to actually make things successful, and not so much in creating nice, cool, fancy videos, which of course is also quite attractive from time to time. Okay, with that, going to the next slide, what we're seeing right here is that simulation becomes more and more integral into the whole business processes of our customers. And that means one thing is that we are integrating into design, into making, into manufacturing, into inspection, and then also into operations. What that also means is that simulation is, and I'm noticing that in all the dialogues we have with our customers, is getting closer to actually also the physical world. It's not anymore something isolated somewhere in an isolated lab, but it's something which integrates more and more with the physical world going forward. And that's something which we are looking into with our ecosystem, which we're building up with Nexus. If we go to the next slide, Ashok. Now, as you all know, and I don't think we need to spend very much time on that one, is that D&E, Hexagon D&E, has a huge portfolio of different simulation applications, which we are bringing to the market. And if you can go to the next slide, Ashok, you know, there are quite some impressive simulations in very diverse areas which we can do. Now, this already is one of the key things which I do want to point out. Simulation is actually very diverse because it's answering to very many different questions. And we go to the next slide. And that is one of the first challenges we see when building a simulation data and process management system. You need to immediately think about the multidisciplinary of this application, because it will not be as homogeneous as you can imagine. And depending on the question, depending on the domain, depending on the application, depending on the workflows you're using, there are quite some diverse requirements which need to be brought under one hood, under one organizational structure. And that's really what we have over the past 20 years worked on, where we had very many successful deployments and where we believe we know exactly what are the key points to make an SPDM system successful. One of the slides I always use, and some of the people who have witnessed my presentation will remember that slide, I'm always using it, but I do want to point out one key part of simulation within the whole product lifecycle management of the system is running a simulation requires in the manufacturing world two ingredients. It requires from the PLM a requirement or an objective, and it requires from the PLM some kind of an information about the product. It doesn't necessarily need to be the full detailed product structure. In the early concept phase, it can be something very simple. And in the late phases in operation, it can be a digital twin information, which you pass as a question into the simulation environments. And then the secret sauce, the simulation magic starts. You simulate results, and then you digest those results as the AI engineer, and then you pass back into the PLM the answer to the question that was articulated. And that typically is a pretty small subset of actually the simulations that you had performed to get to those answers. So what this tells you is, and that's something which I think is important in building an SPDM system, is it's not a data structure. It's not a data extension. What it is, it's a transient system which responds to a question, delivering an answer. And that's the communication pattern which needs to be established. And this is really the start point, the input point, and the end point of any kind of a simulation process and data management solution. Okay, so this is the main part and the main organization. And really an SPDM system is, and Ashok will go in a few seconds into the details about what are the key capabilities that need to be established, need to be part of an SPDM system to really be successful in answering to questions. You notice we are answering to questions. We're not focused on a specific application because the questions will get more and more diverse as the system grows in your organizations. Now, before Ashok starts with his part of the presentation, I do want to make one point about innovation. Simulation is there to react to design, to react to questions, but it's also there to innovate, to explore. And this is something we are seeing more and more, that as part of the question coming from the PLM, there's an element of exploration, of trying out, investigating alternatives, variants, new use cases, new concepts. Now, that means, and you will get more announcements in due course also on this topic of massive exploration in the simulation world. The problem right here is that this generates huge amounts of data. And so even if you are today not overwhelmed by data, the more you tap into innovation as part of your duties in the simulation world, you will get to a point where this is not manageable if you don't have an organizing structural element, because you will just get swamped and buried in all the simulation data that is generated. And that's something where really the next generation simulation data and process management need to pay a huge attention on, is really making sure that we do not only deliver a streamlined automated question answering machine, but that we empower at the same time the innovation, the exploration of concepts, of designs, of manufacturing alternatives, etc., and deal with the data that is coming along with those explorations. And with that, I hand over to Ashok, which will now kind of like go into the details and explain you exactly what there is about the new SimManager system, which we are launching in a few weeks. Sorry, Ashok, your turn.
Thank you, Michael. Thank you, Ricardo. Hello, everyone. Good morning, good evening, good afternoon. I'll take you through some of the feature functionalities of SimManager. How does it enable, as Michael said, innovation and also improving your productivity? Ricardo gave us a little bit of historical background of SimManager, and Michael, um, at BMW, someone called Dr. Michael Holzner successfully argued that a simulation data and management system or solution was required to ensure that the quality and the traceability of business critical simulations are established. Our very own Dr. Michael Schlinkridge, back then with SGI Silicon Graphics, managed the project at that time to develop the CA bench solution on the Virtual Insight platform to deliver exactly that, which is the quality assurance and traceability that Dr. Holzner was seeking. CA bench reduced the data management overhead on the expert users as predicted by Dr. Schlinkridge, who with Dr. Holzner maintained a focus on helping engineers do their work throughout the project. Later on, Dr. Holzner moved to Audi and he continued this drive. He developed these SPDM concept further with their vehicle simulation capabilities, and thus began the journey of simulation process and data management solutions such as SimManager. Michael already mentioned in a week time, we complete 20 years, 2 decades of SimManager as a commercial offering. The origin genesis is a couple of years back, but from the first inception as a commercial product, we would be completing 2 decades in next week. A little view at who we have been collaborating with, some references of our customers. BMW, as I mentioned, started in 2000, year 2000 as a custom solution based on the predecessor of today's SimManager. They kept upgrading. So the first upgrade was 2012. That is when the industrialized version of the current system came into being. BMW has been periodically reporting quantified realization of savings. We can go over the numbers, but they vary on all the domains of simulation cycles, from pre-processing, post-processing, to saving the human efforts and the organizational efforts. Likewise, at our partners at Audi, another anchor user of SPDM solution, they reported a weeks to days reduction in the time it takes them to deliver a new design to a customer. Roughly a 6 times more simulation at the same investment cost and the efforts. Embraer, they automated their entire aircraft program report generation process and reduced the time from few weeks to a single day. So these are some reference indication. Of course, our partners, our customers, and people we collaborate with is a far more bigger spectrum. With that, let's go over what are the key values SimManager has to offer. Data accessibility, it saves you time in searching for the data. We are all different, and so SimManager offers variant different means by which you can access your data. It can be pedigree or the audit trail viewer, which gives you a graphical dependency graph view of your data, backward traceability as well as forward traceability, list view, tables, search tables, where you can search by the columns, by types, category search. If you already know what's the artifact you want to look after, you have the categorized search, and a more general purpose Google-like search. You remember certain phrase, a program name or a part number, and you don't know other contextual information. You put in that single phrase and you get the related data artifacts. Traceability, it saves time to understand the data. Again, we insist that traceability, both backward and forward, is the backbone of any SPDM system, SimManager included. It helps us understand what, how, why, who, when, as well as where the data is coming from and where it is being consumed downstreams. At the same time, we need a smart and seamless import and export mechanisms. It helps reduce the risk of using the wrong data. Often a case historically where data is managed more manually. CI community is one of the most organized community. But at the same time, there are risks where we see that the wrong version of a file or an include file gets used, and it gets detected very late in the cycle, sometimes even when the product goes into the production, and bang, you hit the problem. Systems like SimManager help identify that. There is no pain to populate the databases like that, and there is no pain for end user to find the correct information for their usage. Most of these tools capabilities come out of the box, and we strive, and learning from these 2 decades of knowledge, we want to internalize all this knowledge so that our customers, our partners get out of the box experience. While we stay flexible, we stay tools agnostic, but we want to capture as much of the industry knowledge as possible and offer that out of the box. We can talk about the effective collaboration. It has always been the case, but in recent years, we see an explosion of distributed teams. It's not just distributed compute, but teams are not just discipline-wise segregated, but also we have a geographically distributed teams. So everyone wants to, different departments want to have their own workflow orchestration. We want the globally distributed team to access the single source of truth, and all those can be enabled by a central source of truth like SimManager. In terms of managing the data, Michael gave us a preview of the diverse disciplines that the current simulation world has to deal with. 1D, 2D, 3D, system dynamics, FEA, CFD, NVH, etc. We need a system which understands all this data model out of the box and is flexible enough so that it can be tweaked as per the customer needs. If they have specific metadata, attribution, terminology, best practices they already have incorporated, we should be open to embed that into system like this. With that, let me give you a little bit of fast facts about SimManager capabilities. This is a tool which is designed for simulation world specifically. So somebody say, hey, I have a PLM PDM system. Why can't I just use an extension of that? I have all my designs there. Yes, talk to the people who have tried that. So this is SPDMs are the solutions which are designed for simulation world. They work integrated with PLM and PDM systems, but we need specific workflow orchestrators which can go all the steps from CAD to the final simulation report. It helps you prepare the work. So you need to have a project hierarchy. It can be OEM if you're a supplier. If you are OEM, then you can have the hierarchy based on, let's say, your program, your vehicle program, SUV, or a particular platform. Underneath that, you would want to organize your work maybe by disciplines or the domains. And you would want to define your studies, your scenarios, your load cases, and target it. Once this hierarchy has been established, you would want to perform the work, execute the work. And what is that? Starting from design, you would want to maybe clean those up, pre-process them. So make the mesh models, include files, add load and boundary condition, construct the run ready deck, the input deck, send these jobs to either on-premise HPC or to the on-cloud compute capabilities as available today. Out comes the result files, result one or more files, ASCII or binary, which are good to keep, but what you're interested in is the KPIs or the key results. So you want to do the post-process, standardized post-process that will give out the key results, the curves, the values, the animations, etc. And at some time you would want to collate all this knowledge which came out of the physics-based solver and prepare simulation reports and compare whether the outcome, how does it fare against the target KPIs? Does it meet the environmental norm? Does the engine is fuel efficient? Is it lightweight enough, etc., etc. So in order to do that, we need to reduce the data chaos. The data volumes are just going to go higher and higher. We need to reduce this data chaos and make data auditable and dependable. We need seamless capability to capture this disparate data in a central, secure, and searchable environment. We also need search and the sort capabilities which can sort terabytes of data to get the most meaningful insights. most meaningful design insights automatically. At the same time, we also need some business rule-based data compression and retention policy. Do I keep all this intermediate results and data files forever? Certainly not. So we need to, and every organization might have their different preferences around that. So tools like SimManager enables them to define these rules that certain data files beyond a given duration of a size higher than this should be cleaned off. Maybe the KPIs, the key interest, we can preserve them for a longer period. And as we'll see in the following slide, make some meaningful usage out of that using the latest tech around AI MLs. With that, this is around the data management capabilities. We also need seamless capabilities to submit our jobs. You have your data simulation artifacts in SPDM system. You want to run your jobs. You should have a extensive enough framework to run one simulation at a time. Or if you're running design of experiment, you should have a capability of running large number of simulations at a click of a button. This certainly would need some expertise beforehand to define such studies, design of experiments. But the tool should support that. So we have what we call the simulation generator, where you can define such automations. And at a click of a button, some of our close partners, they run thousands of simulations. On a Friday evening, they click the button. On Monday morning, they come and they have the simulation reports ready. And that, in my opinion, is the best use of the engineering mind that we have. The HPC integration, these are needless to mention. We need all this capability support for the queuing, different queuing systems, and the trend, the hybrid. Customers have their traditional HPCs on premise. They would keep it, at least part of that, but they want to augment that and make use of the elasticity of the compute cloud, and on the need basis, divert the jobs certain category or size to those. With that, let's go to the last bucket of capabilities. That's the collaboration. Collaboration between whom and what? Collaboration between people, processes, and data. You cannot have a black box where you have all or none access. So you need rule-based, role-based, profile-based access rights and executable privileges. Likewise, for the globally distributed team, you need a central source of truth. But let's accept the fact we have the network latencies, and how do you take care of that? If I have a SPDM system in Munich accessing it from Pune, Mumbai, or Paris, it might have a different latency times and network effects. So for that, we take care of that by offering the multi-site capabilities. This enables having more than one site where the data replication happens on the rule base. And we can also have some satellite sites where the data resides closer to the compute capabilities. And of course, for all this, we need some task management system, and we offer work request and the project overview for that. We need seamless way of creation of tasks, automatically assignment, and the due date reminder, wherein all the required inputs are mandated, and there can be some optionals as well. And we have some key KPIs defined beforehand. If you complete this task, a meshing or simulation, these are the KPIs that are expected out of that. With that, let's have some preview of how it is being offered in the latest SimManager, which is going to release in few weeks. One underlying message I want to restate is some people have been using SimManager for quite a while time. What's the difference now? The difference is not just state of the art, brand new user interface and experience, and these two things doesn't have to be same, which is high in responsiveness, high in interactivity, and most importantly, it's persona based and intuitive. Our goal is to make SPDM system as out of the box as possible, at the same time offering high configurability so that it can adapt as per your data models and best practices. Michael mentioned that our initiative, our roadmaps for SPDM solution in Hexagon are fully aligned with the overall Hexagon vision, and it is completely in sync with the platform initiative, what we call Nexus. There are 2 more webinars, one each Thursday for next 2 weeks. We will explore far more in detail this capabilities of the new user interface and the experience. But here I try to give some glimpses of what it can do, how does it look like, how does it smell, taste, and feel like. And on the following webinars, we'll go and take a deep dive around these topics. Schema structure, we said we have multidisciplinary data. So we need to have the data model which can spread across the spectrum. SimManager can deal effortlessly with various simulation types, course simulation, change simulation, 1D, 2D, 3D. Traditionally, a lot of time was wasted adopting and adjusting these import and export interfaces because different tools have different formats. How do you store them? In what system? It defined what kind of attribution metadata you extracted. And this is also due to the high variability in how the data is imported and stored in different systems. Coming from PLM, it might have PLM XML and so on. We solve this problem by formalizing the import structure, which make it much easier and well as close to out of the box as possible. How do we do that? We bring intelligence during the import. At the time of first interface, the data gets pumped into the system. We bring in intelligence by what we call automagic importer, on which in the next webinar we'll elaborate. For now, the underlying message is we have a seamless, effortless data ingestion. And at the time of import, we need an appropriately annotated data. What does annotated mean? If you have an input deck, we want to maybe extract certain metadata already extracted automatically without manual intervention. We might want some automatic enrichment. Now, enrichment can mean different means. It can be from your design, mesh, input deck, or result. If that is what you are ingesting into the system like SimManager, you want to generate 3D lightweight viewers. You might want to generate some mesh quality statistics and so on, so that you can flag okay or not okay if that input deck or a mesh model is to be consumed later on. With that, I think we just saw one example of how the data can be imported. This is based on the bulk importer, but the more interesting one is the automagic one. For that, you and me included will have to wait for the next webinar. You see a general user experience enhancements. This is something I don't want to talk explicitly, but once you get hands on this new tool, you will see all the feedback in the recent months and years. This has been ingested, be that the persistence tree, like you don't have to hop around different workspaces. Hey, I like to work with the tree, good. But then I go to an exit and then I lose track of my audit trails. Hey, I like to work with the search tables, but then I lose the tree. We have tried to address those kind of concerns. The system is, well, it's taking initial few steps towards low code and no code. So the individual users, based on their persona and interest, can tweak the system. If somebody like to work with the tree, great. Otherwise, shove it off on one side. If somebody want to work with the more search way of dealing with the data, they can do that. Otherwise, we have other structures in which they can access and manipulate the data. With that, let's try to see other capabilities, finding your data easily. There are different profiles and different personalities. That's why we need different ways of looking for the data. We should have dashboards, and dashboards should not be a wall of data. It should be not colorful enough for the sake of aesthetic, but for the sake of functionality. If there is a statistical data, we should have the pie charts, the bar charts, and likewise for if it is a numerical number over a timeline, we should have ability to plot them right in the dashboards. Trees, some like it, others don't. The trend of the industry is to get away with the tree, but I am somebody who like nature. Be that in nature or software, I think keep the trees for until we have the powerful enough capabilities in rest of the features where we can get rid of trees at some time. We need easy search or the e-commerce like search. You put in a string and it finds you categories and filter. Traceability, and you need comprehensive enough comparison capabilities. That can be value comparison, it can be file comparison. You have a baseline image or a movie and you have the simulated one, or a first shot, second shot. You want to do a overlap of them and see how do they fare against each other. You need file comparisons. Of course, we are not in the business of file comparisons at all, but once you have the ASCII files in the system, you would want to see how, let's say, some multi-body simulation kind of file, which are primarily small file ASCII files. You want to see what's the parameter difference between them. And if you have assembly, as most of the designers and manufacturers do have, you would want to know what particular part has swapped. Usually it would be one part or two. And if it is the same part, has it varied in a particular revision which is being used or not? Needless to say, once you do the extraction of KPIs, you would want very comprehensive plotting capabilities, spider plot, bubble chart, etc. With that, once you have found or were able to successfully find the data of your interest, you would want to analyze and decide what to do next. A precursor to that, of course, is how do you organize your work? You would need to create the scenarios or the load cases. What are the different simulation conditions you want to simulate, and define your objectives in the form of target KPIs. The system should allow seamless creation of these target KPIs. Define your load cases, run the job, get the computed KPIs, and match those against the target KPIs. And then you can say okay or and okay. Accordingly, you either optimize your design or go ahead with the production. You also want to create your trade-off studies and define your alternatives, and in the process assess your alternative across your objectives. So that is enabled in the form of, we have the object viewers. You get all the required, and don't get me wrong, we offer something out of the box with an experience of 20 years. But if you come back and say, hey, this is not the metadata which is good enough for our, these are very easy to change metadata displays. So no coding, no programming IT skills required, either directly on the UI or with simple XMLs. You would be able to change the behavior of your system uniformly across for all or just for yourself. We spoke of the comparison and of course reporting. This is a topic which has many facets to that. What does reporting mean? If we have a dynamic enough dashboard, for me that's a report. But then there are organizations which needs more formal way of reporting. In some cases, you might even want to take a PDF, print it out, sign it, upload it back as a system of record. We support this entire spectrum of that. And if you make some changes in the initial inputs, you can rerun the entire journey from design change to the final report at a click of a button, and then you can compare the two reports. Okay, what else do we? Traceability, we cannot emphasize this enough. We have the 360 audit trail from geometry import all the way till simulation report. It gives us the full visibility of the audit of data connections. It can be component, include files, etc. Based on the data extraction, of course, as well as all the way till running the assemble jobs, the solve, the post process, and the report. We need this backward and the forward traceability. Pedigree can be, or the another word for the audit trail is the pedigree. It can be drawn from any given object, and you would know where does it come from, where does it gets consumed. The P in the SPDM is process, and we need to have traceability of the process as well. So we have a process viewer or the process view audit trail that helps you trace all the processes that ran related to a given object, how that object was being created. Was that manually imported, or that came into being by submitting some jobs and out came some output from the HPC, and these are the results and the key results. So you need which CAE tool, pre, post, or solve was used for generating this given artifact, which version of that, and so on, who ran it, when was it ran, etc., etc. So all that is captured in our process viewer. Okay. This is again re-emphasizing the fact from concept to customer, which is we accelerate the innovation by being the single source of truth. And the SimManager can effortlessly construct the models from the design, from concept design to optimized design, adding the load cases and initiating anywhere from single simulation to thousands, all while enjoying in-browser 3D visualization of models and the results. This is done, of course, with the help of our partner at Vicolab. Now let's talk about something a little bit more. I already spoke on the process management. This is again an underlying topic for our very next webinar, which is on enhancing your simulation throughput. That will happen next Thursday, but I'll just briefly touch upon what's the spectrum we are talking about. SimManager can connect to your existing tool set ecosystem. If a tool has to be learned or pushed down to the end user, that in our opinion is not the right way. The tool should be easy enough to be adopted. It should give tangible value to the end user and the business people with business objectives in order to be successful. So DNE Hexagon has its own CAE portfolio, a wide buffet of that, but we understand the customers can pick and choose the best one of their choices. And most often than not, we see a heterogeneous mix of different CAE tools. Okay, we don't have to name the names, but we know for certain preprocessor what would be the choice in a given industry, in a segment, in a region, etc. And SimManager, tools like SimManager have to be tools agnostic. It should be easily able to fit into the existing toolset ecosystem. We don't want our presence to be disruptive in a negative manner that, hey, you need to have particular tools from us in order to use. No, that is where we need seamless integration, getting the CAD from PLM, PDM. We should be able to make these designs available to different CAE departments and maybe back and forth between them, doing this CAD to CAE loops, and finally ensuring the digital continuity around that. With that, I think we don't have to go over the detail, but the theme is SimManager is an open and tools agnostic system. While we love our own tools, but we don't shy away from easy integrations, sometimes out of the box, sometimes with click of a button with other available popular CAE tools, pre, post, and solve. And let's talk about collaboration. SimManager fosters collaboration not just with people, but with the corresponding associated processes as well as data. It promotes seamless collaboration between different CAE domains. When you are building a car or aircraft or a pacemaker, the NVH durability or electromagnetic simulation, they cannot live in silos. They have to interact with each other. Finally, they are going to come up with an optimized or the final design which is going to manufacture. So this collaboration is imperative. It's not a choice. So SimManager promotes such seamless collaboration between these CAE domains and globally distributed teams, providing a scalable and auditable environment, which in turn, of course, enhances the productivity. How do we do that? One way, as I mentioned earlier, is the multi-site capability. You have globally distributed teams. If you host it at just one place, no matter how many load balancer or extra compute or IT infrastructure you add, the globally distributed places will have inherent network latency, one place less, another place more. How do you address that? The answer is distributed systems who talk to each other. That's what any other big enterprise solutions will do. Likewise, so SimManager has the multi-site capability. Fundamentally, we have SimManager instance at the major sites. One may be in Asia, one in EMEA, another in Americas, etc. And they synchronize with each other. How do they synchronize? They have to synchronize based on the business rules. Maybe you don't want to synchronize every data from every site. That would be crazy. Well, not exactly. You might want to do that, but you certainly want, let's say, a data of a certain maturity, something which is shareable. You can decide that one as a criteria. You can decide if a particular program or a project is to be shared with the other region, that can be another business criteria, and so on. So rule-based synchronization, it has to be automatic, as well as it should be on demand. If certain data is not replicated based on this rule, there should be a provisions by which someone who want to consume should be able to demand on-demand replication. And of course, whoever is the owner will have to approve, saying, hey, that's my data, I decide whether it's consumed or not. Okay, so not just that, we also have the concept of satellite sites. So you have the major sites where such replication happens, and then you have 4 or 5 team members working in an office with the local compute and so on. So we support such concept of satellite sites as well. Work request, close to my heart. It enables us assign tasks and track progress through template-based work request. What does that mean? The different departments will have different steps to be performed. We can see a general pattern there, but you would always find a little bit of intricacy specific to that department on what steps do they perform. Not just distribution or the delegation of work, it also helps you organize the workflows and the monitoring of such tasks. So our workflow manager capability enables you to automate all this task delegation, creation of such repetitive tasks, and streamlining them with your engineering teams to be better and smarter at what do you do. Okay, one point we should see here, those who have used work request earlier versus what you see now, we have taken a conscious shift decision towards agile planning and task management tools. You would see more and more incorporation of such tool. We start with a Kanban board. And one point I can highlight is this, of course, is learning from you, the audience, the customers, the partners, as well as our friends in the form of competitions. These are the best practices that industry need, and we together as an ecosystem need to address that. So we are starting with the Kanban board, but we have plans for incorporating what is called simulation planners, the statistical historical planning of the SimManager, forecasting of the simulations, and other such things. That brings me to looking forward. Where are we looking at? What are the product directions? These are certain themes around which me and Michael strongly feel, and we are lucky enough that the corporate echoes our sentiments. So we cannot stay aloof of the tech in the AI ML. We cannot say no to the collaboration. It is imperative. It's here to stay. Performance, we can always have performance not just for SPDM system, but our physics based solvers and other tools that we user experience. One of our very close partners and customer, the very first interaction we had with them, hey, what are your SPDM requirements? They said we have 3 requirements: user experience, user experience, user experience. And then they meant it. Then of course we spent days and weeks elaborating what can that mean in different forms and functions. And I'm glad we started taking such feedback and incorporating. Cloud data management, we spoke on that. Make your data work. Recently, I attended few user conferences, and the one underlying theme was AI ML in CAE is no longer just a remote word. It's happening right now, right here. People are making use of the tremendous amount of data they have generated over time, and they want their data to work. Will it replace the real simulation at all? I will not comment, and I cannot comment, but it certainly complements the real simulation with these predictive models. How can SPDM like SimManager facilitate such workflows? One possibility could be generating this training set, X and Y and the inputs for training your data model. You have your input deck, run ready decks already in place. You need some hook points in system like SimManager wherein you can extract certain parameters, do some sensitivity analysis, and identify, hey, these are the 5 or 10 parameters which I should be, playing around, tuning in and out to have my predictive model more accurate. We saw it across the industry. We saw it from aero, auto, consumer goods, electronics, medical devices. Everybody is doing it right now. And we as a SPDM provider should enable, just make their life a little more easier. Okay, this theme echoes very distinctively in all these user conferences. I was baffled at some of the papers being presented, and it just impresses me. Now, what do we intend to do with SimManager? In-house, we have a tool called ODC, which has a different offerings. It has plans around the real-time CAE processes, learning from the images. A lot of time we have extracted some key result images, which stays in the SimManager system. We would want to make most use of them. Maybe we do some feature extraction from these images and do some predictive modeling and so on. Cloud, Michael's favorite topic, and slowly becoming mine as well. If we were discussing 5 years back, we would see a very clear hesitation. Hey, I'll go to the cloud. I won't go to the cloud. Not anymore. Now we see a very clear consensus that cloud is the direction everybody is going. Does that mean tomorrow everybody would be on cloud? All their tools, functionality, data would be in cloud? Certainly not. It's a journey. It's a journey we have a general consensus on. So we will have to strike a fine balance between on-premise and cloud. There are on-premise needs, certain sensitive data for specific domains, industries, regions might still need to be on-premise, and then some of the things can move to the cloud. The general trend we see, and it is echoed by a lot of different studies, is process first, data next. We see a general trajectory where historically, if everything was on-premise, people are willing to move their compute out, which is supplementing their HPC on-premise HPC, reducing the capex there, having some bare minimum HPC compute power there, and then make use of the cloud's elasticity on the need basis. On the market cycles, you scale up and down using the cloud. So we, as a CAE vendor as well as enterprise platform provider, need our strategy to be aligned with this trend. We need to support all the three modes. Fully cloud, that's what Nexus, you should hear more on that. On-premise, SimManager has been awesome at that, and the hybrid journey, bridging these two. So that's what we have to offer. SimManager is a web-based solution that can be deployed currently as we speak on-premise, of course, and on the private cloud. We do not have a public cloud or the SaaS offering yet. This is for known reasons. We would try to address them in coming time. But what we already enable is this journey. We don't want this cloud journey to be disruptive. That is why, as we speak, we have reasonable number of customers who have their SimManager deployments in all these three buckets. We have customers from SME to some major OEMs who have their entire SimManager system completely in cloud. That is where, if cloud experts are to be believed, that is where the most value is. Finally, if all your tools and systems and data is in the same system, the IO, latency, etc., goes down, and that's the best use of the cloud. But that's a target, should be for most. There's a journey, and that is where we have OEMs, two suppliers who have started this journey, and the first step is they move their compute out. You have your SimManager system on-premise. On the rule basis for a given domain or the simulation time or a size, it can divert the job submission either to your on-premise HPC or to the compute. That's what we enable. As a next step, it is moving the SimManager to the cloud and then making most of that. Cloudify SimManager. This is another offering from Hexagon. We call it Nexus Compute. It's, as we speak, it's a pilot is already available. It enables you access to all the Nexus products, majority of the D&E products as well, and others will add. Our next milestone in the roadmap is integrating SimManager with this. But don't get me wrong, we are not going to be bound by this Nexus Compute integration. It would be there. At the same time, we said we would be flexible enough, as we have been proved to at many other customers. We are equally open and compatible with any other player. So the spectrum across all the major AWS, Azure, GCP, we have production systems running in all the three buckets there. Okay, conclusion. What do we take out of this? What we are launching in 1 week, it's not just new UI, but a new direction of making things easier. Incremental steps towards low code, no code. Big word, but that's what our intention is. We want our IT footprint to be light. What we are taking, of course, are the initial steps. We want democratization of SPDM, which is you don't have to be IT experts either to configure, run it, or certainly not to use. You are engineers, analysts, and decision makers. That's where is the best use of your mental power and energy. We need, in order to supplement this, we need smart and seamless data ingestion. And we have learned the trick based on our 20 years of experience, what different domains or cross-domain data models should be. We incorporate that out of the box. We need central source of truth with built-in traceability. This enables innovation. This in itself is not innovation, it enables innovation. Make your data work. We are open, that means tools agnostic. So we integrate with any and every CA tools available, which is popularly used by the CA community, either out of the box or with the help of our services team. At the same time, we are flexible enough and configurable enough to adapt to the customer, your specific concepts, best practices, and data. We enable new technologies and technological trends like AI, ML, and others, and put your data to work. More out of the box capabilities. Historically, like it has been a risk factor in every single SPDM deployment, which is this humongous iceberg. You have a software which is a tip of an iceberg, and then you have this never-ending services or extension or customization configuration going on. That's what we want to reduce. And I would request to the industry in general, that's the direction we all should take. Minimize this iceberg effect of having too much services. That is where we can really be efficient. If we can make the product more closer to what end user expects, we can laser focus our energies and expertise on really enhancing innovation rather than, hey, I don't like the tree this way, hey, I don't like the, let's say the graph this way, etc. So choose SimManager and unlock your potential for success. Contact us today to get started. Our SPDM experts, and we have enough spread geographically in all the major regions wherever you come from. Our SPDM experts will work with you to quickly assess where you are today and craft a tailor-made action plan customized to you. IDs for Michael and me, feel free to reach us wherever you find us, LinkedIn, Teams, email.
Everybody should try it. It's something new. Experience is totally new, and it's actually enjoyable to work with an SPDM system, which you cannot very often say from a data management system.
Echoing your words, Michael, think big, plan smart, start now.
Exactly.